information, we're given what topics are going to come up within various categories. And paper 2, we've got some more ratio questions and the product rule. Right, so now let's look at ratios. We're going to look at ratios. Now, ratios are just fancy ways. So if you've got A to B, it's the same as saying A divided by B. So now we've got A to B to C, and we want everything in terms of the same thing. So I'm going to check out A and C. So A to C is 5 to 2. So that essentially tells me A over C is 5 over 2. So 2A is equivalent to 5C. That means 4A's will be the same as 10C's. So we're just going to put everything in terms of C. Could have put them in B's or A's, it wouldn't have mattered. There's no good reason why I chose C, but I think it's going to work out nicely. Hopefully it does. Then we're going to look at B to C. B to C is 3 to 2. So B divided by C is 3 over 2. So that tells us 2B's is equivalent to 3C's. So we have 3B's on the other side. So 1B would be 3 over 2C. So 3B's would be 9 over 2C. So now if we plug that all in, we've got 4A, which we said was the same as 10C's. So 10C minus C equals 9 over 2C, which is the same as 9C to 9 over 2C. And the C's and everything cancel, and we will end up with 1 to 1/2 times both sides by 2, and we get 2 to 1. So 2 to 1 is my ratio, and I've gone through a long way of doing that just to show you the relationships. You may have come to that, it's only 2 marks in one line, and that would have been perfectly fine. Next bit, we're given m double dot n equals 2 to 5. So that tells us m divided by n equals 2 over 5. And we want m in terms of n. So we want m equals something. So I'm going to multiply the n up here, and we're just going to get m is 2/5 n. Now we need that for the next bit, so let's write it up here. M equals 2/5 n. So now we're given a to b, so remember we can write that as a fraction, is equal to 10m over 3n. Oh, we don't actually need to write it as a fraction, but never mind. Right, now we want to get rid of essentially the m and the n's. But let's see what we know. We know that m is equal to 2/5 n. So 10m will be 10 times 2/5 n. That's going to cancel and give me 4n. So now we've got a over b is 4n over 3n. We can cancel out the n's, and we can see a to b is 4 to 3. So our answer will be 4 to 3. The final topic that we're going to look at is the product rule for counting. Now, the reason it's called the product rule is that product means times, so you're multiplying all the different possible outcomes, okay? So your product essentially means multiply, and you're looking for all the different outcomes. So let's have a look. Our first question asks us how many odd numbers are greater than 30,000. So that's our important bits of information. We want it to be an odd number. Okay, so an odd number can't end in an even number. So that rules out 2, rules out 4, rules out 6, and rules out 8. So our last value, the only possibility is 7, okay? We want it to be greater than 30,000, so my first value can't be smaller than 3, so we can't use 2. So the only options are 4, 6, and 8, because remember 7's been used up. So my first value has 3 options. My second value can be any number except for the 7, so that rules it down to 4, and except for the one I just used as my first value. So there's only 3 options. So now those 3 options left over, one of them can be used for the third value. There's only 1 left for the 4th value, and there's that 7 there. So we get 3 times 3 times 2 to give us 18 possibilities. The final question, which is also on the product rule, you're looking at digits 2, 4, 5, 6, 7 and 9. You want them to be greater than 60,000, nothing is repeated, and an important bit of information here is you're using some or all of the digits. So we're thinking how many integers can be made? Now, we could have all 6 digits, at which point it doesn't matter what the first value is. So if we look at 6 digits, you could choose any number, because even if it's 2, it's 200,000, which is bigger than 60,000. So here we've got, could be any of the 6 numbers. The next one is any of the 6 except for the one you used to begin with. So that's 5, and then 4, then 3, then 2, then 1. And so this is a calculator paper. This is actually called a factorial, but you could type it into your calculator. So you do 6 times 5 times 4 times 3 times 2, and that would give you 720. Now, if we were to use 5 digits, we want it to be bigger than 60,000. So the only options for the first number are 6, 7 and 9. So we've got 3 options for the first number. For the second number, it can be any of the 6 except for the one we've used to start with. So we've got 5 options. And the same for the third number will follow suit, will be 4 digits. The 4th number will be 3, and the 5th number will be 2. So we end up with 3 times 5 times 4 times 3 times 2. So 360 possibilities. So the total will be 720 plus 360, which gives us 1080. So we've got 1080 possible solutions. Expanding triple brackets. The easiest way to show you this is actually to just take an example. So here's an exam question. You've got to show that we've got a triple bracket minus another x multiplied by a quadratic, and we're looking, and then we're going to have to factorize it afterwards. So let's take the first 2 terms. And I'd always suggest you make your working super clear. In case you make a mistake, you're getting marks each time you're multiplying out. So if I take these, I've got x times x. So I've got x squared plus x plus 3x plus 3. So altogether, I've got x squared plus 4x plus 3. And out of the 5 marks, that's essentially 1 mark. I'm now going to take my quadratic, which I've multiplied out, and I'm going to multiply it by x plus 4. And when I do that, I multiply everything by x first. So x cubed plus 4x squared plus 3x plus 4x squared plus 16x plus 12. Right, and then you're going to simplify that. So altogether you end up with x cubed plus 8x squared plus 19x plus 12. Right, so that's opening out that first batch. Now altogether you've now got 3 marks. So we've got the other 2 marks to get, and we take what we've done, 19x plus 12 minus, and remember it's the whole thing minused. So what I would do is actually take every number and every value, or not number, they're not numbers or values, every letter or expression within that bracket and multiply it by minus x. So you're not doing too many lines and you're not confusing yourself. Because if you're going to go wrong on this, the likelihood would be that you would go wrong when you're opening out that expression. So we've got x cubed minus x cubed, so that disappears. 8x squared minus 7x squared, leaving us with x squared. 19x minus 11x, leaving us with plus 8x. And then we've got 12. And we want to be able to factorize that. So I'm looking for factors of 12, which add up to 8, which is 6 and 2. So there's our first expanding triple brackets. Right, next we're going to be looking at a question where they don't give you something and they talk about coefficients. So remember, a coefficient is effectively the bit in front of. So the coefficient of x squared is the bit that's going to be in front of your x squared. Right, so let's open this out first. So we're taking the whole of this bracket and multiplying it by x. So we get x cubed plus 5x squared plus kx. We're now going to take the whole of the bracket again, and this time we're going to be multiplying it by minus 3. Minus 3x squared minus 15x minus 3k. And we want to know our coefficient of x squared. So I'm looking for everything that is in front of an x squared. So that's in front of an x squared, and that's in front of an x squared. And we know that's equal to everything that's in front of the x. So in front of an x, we've got plus k and minus 15. So now we've got 5 minus 3 equals k minus 15. So we'll have 2 equals k minus 15. Therefore, k equals 17. So k equals 17. Right, next questions. Right, some more factorization. And here is where the difference comes between your GCSE and your further maths. Right, we've got something like this and you're like, what do I do? I know we've got squares. So you see squares and you think, okay, 2 brackets. Okay, I know that the first value times the last value has to give me 6x squared. And I know the last one times this one gives me minus 20y squared. So we're going to go about and think about how we do that. But hopefully you realize before you even start that everything goes into 2. So I'm actually going to take 2 outside the entire thing first. So I get 3x squared plus 13xy minus 10y squared. Right, so I've got to this point and it makes it easier now because there's only one way to get 3x squared. I've got to have 3x and x, right? Which makes it a little bit easier because now I'm thinking of 10y squared minus 10y. Now I know if I use 10 and 1, 10 times 3 is 30, not going to give me 13. And then 10, if I had a 10 here, if I had a 10 over here and a 1 here, I've got 10 and 3, but there's no way for that to become minus 10. Because even if I had minus 10x, and then this would have to be plus, and then we're not going to get 13. So we know we're not using 10 and 1. Other factors of 10, 2 and 5. If I had a 2 here, I'm going 3 times 2 would be 6. And then I've got 6 and 5 together, it's not going to give me 13. Let me try the other way round. 3 times 5, 15. And multiply these two together. If this was a 2, we're like, okay, great. 15 minus 2 gives me 13. So the way that you think about it is if this is a negative here, you know that you want, so if this is a minus, you know that you're taking away these two multiplied by each other to give you this. So we end up with 3x minus 2y and x plus 5y. Another way that you can do this is you can remove sort of the x or the y, and then as long as you put it back again. So for example, if it's easier for you, say I had 3x squared plus 13x minus 10. Okay? And I know that you might use the method where you do 3 times minus 10 and you get minus 30. And then you're looking at factors. So you go, how can I get 13 from that? So I've got 30 and 1, that doesn't work. 2 and 15, that works. So I can do 3x squared plus 15x minus 2x. So I replace. So this is made up of these two, minus 10. Then I take my first two terms and take a common factor. In this case, it's 3x. And I get x plus 5. And I can take x plus 5. I want x plus 5 here. So I get minus 2. So factorize, this gives me 3x minus 2, x plus 5. And then what you can do is the numbers on their own, put the y back in. That's also a perfectly valid method. So my final answer, don't forget the 2 there, is 3x minus 2y, x plus 5y. I hope that makes sense and I haven't overcomplicated it. But if you find that difficult, get rid of one of the letters. So the one that's at the end, factorize and stick it back in again. Okay, index rules. Right, so we know from GCSE, we know if we've got x to the power of something, the x has to be the same, so that base number has to be the same. We're going to get a plus b. We know when we divide, we can take away the powers. We know when we do everything to the power, we're actually multiplying. And then we come to things that are a bit more complex, where we know that x to the 1 over n will be the nth root of x. And x to the minus n is 1 over x to the n. So we've got our rules. And also always, 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 x to the power of 0 is always 1. Now, obviously, when we move things to the other side, we're going to do the opposite. So in this question here, you've got 3 minus root x to the third equals minus 2. Now, to the power of a third means the cube root. So what's the opposite of cube rooting? So that's going to be cubing. So for both sides, I'm going to cube, which means it gets rid of the third on one side, and I've got minus 2 cubed. So we've got minus 2 times minus 2 to give us plus 4 times minus 2 to give us minus 8. So we get 3 minus root x equals minus 8. I can take away 3 from both sides. So I'll get minus root x equals minus 11. They're both negative, so I can just make them positive. Root x is the square root of x. The opposite of square rooting is to square it. So 11 squared gives us 121. Here they're telling you what to do. But if they hadn't told you to multiply both sides by x to the half, how would you have known that was what you needed to do? So the way that you could have looked at this is to say 2x to the power of 3 over 2 minus 3x to the half equals 7. And because x is to the power of minus a half, we know that it's on the bottom. Because remember, x to the minus n is 1 over x to the n. The 7 is not to the power of anything. The 7 doesn't also go on the denominator. Be very careful about that. Okay, so I'm looking at that. I don't like things on the denominator. So I'm multiplying everything by x to the half. So I get 2x to the 3 over 2 times by x to the half minus 3x to the half times x to the half equals 7. When we times indices, it's the same as adding them. So 1.5 plus a half is going to give us 2. A half plus a half just gives us 1. So we get 3x. And we can bring the 7 over. And there we go. We've got a quadratic again. And because it says 3 significant figures, we we know that, we're going to be using the formula. If it's a calculator paper, you can just stick it into your calculator. And it will be a calculator paper actually, because you won't be able to do the square root without it. So you can put it into your calculator and sort of work backwards. The other alternative is to use completing the square. So in your calculator, if you've got the Class Whiz calculator, you can tell menu, equation function, polynomial, degree 2, and we're going to do 2 minus 3 minus 7. And it gives us our roots, and it will give us our answers. But because we're asked to show our working, you could either write out the formula. So there's two methods to do this. So if I say method 1, you're going to say A equals 2, B equals minus 3, C equals minus 7. And you know that X equals minus B, X equals minus B plus and minus the square root B squared minus 4 times 2 times minus 7 over 2 times 2, and then just read off your answer. So we're going to read off our answer. So X equals 2.77 or minus 1.27. Now, which one isn't valid? Remember, we can't take the square root of a negative number. It's illegal. Dividing by 0 and square root of a negative number. If X was minus 1.27, over here, where you've got X to the half, you would be taking the square root of a negative. So, to cross through that, that's not valid. So this is our answer. That's the first way to do it. And you're just sort of writing out your entire formula and then using your calculator. The other method, so say method 1, method 2, would be using completing the square. So step 1, I would take that equation, and because it's got an equal sign, I can divide it by 2. So x squared minus 3 over 2x minus 7 over 2. I can now complete the square. So I can do x, half what's in front of the x, 3 over 4, squared, minus 9 over 16, minus 7 over 2, equals 0. And you could double check that was correct, because your calculator also gives you the minimum, which we can see is 3/4, and the y, which is minus 65 over 8. And then we can rearrange that. So we get x minus 3/4 squared equals 65 over 8. Take the square roots, so you get plus and minus, and you end up with exactly that. So it doesn't matter which way you do it, you're going to show your working, even if you've just plugged it into your calculator, and your answer is 2.77. Okay, now we're going to go to linear and quadratic inequalities. Linear inequalities, a lot more straightforward. You treat it like an equal sign. If you've got a double one, whatever you do to one side, you have to do to the other. With a quadratic inequality, I'll show you how to do it if you don't have your calculator with you and it's a non-calculator paper. However, if you have your calculator, you can always check things because you've got an inequality button on the Class Whiz. If you haven't got the Class Whiz, that's fair enough. If you're going on to do A-level, you will need it for A-level, so you might as well get it now if that is a possibility. Okay, so let's take the first question. It tells us to work out, and they bold things for a reason, that's there to help you, the integer values. So these are the whole numbers. But first, we want to get x on its own. So if we have a look, we've got 4x plus 3. So we're going to minus 3, and because there's two sides to this, we're going to minus 3 on both sides. So if I do minus 5 minus 3, I'm going to get minus 8. 13 minus 3 is going to give me 10. Now I want x on its own, so I'm going to divide by 4. So when I do that, I have to divide both sides by 4, which leaves me with x minus 8 minus divided by 4 is minus 2. And then we've got 10 divided by 4, which is the same as 2.5, 5 over 2. So let's write it because we're trying to 2.5. And now we want to list all our integer values. So we know x is greater than minus 2, but not equal to, because it doesn't have the equal sign. So it's not going to be minus 2, it's going to be minus 1. Next one up, 0 is an integer, 1, 2, and I can't go any further. So those are all my integer values. Right, work out the range of values for which x squared minus 11x plus 28. Step 1, factorize. So I'm going to do that. X and x. 20 factors of 28. There's a plus here. So factors of 28 that add together to give me minus 11. So we're going to say, well, 7 and 4, and it's going to be minus and minus. And so I've got what we call our critical values. So my critical values are 7 and 4, because if I was to solve this equal to 0, I would get 7 and 4. There are a few ways to do this. First way is, which you may have learned, is to think about it's a positive quadratic, so it's a smiley face, it goes through 4 in my very dodgy graph there, and we're looking for wherever this graph is above the axes, meaning if I take any value of x and I read off the y, it's always going to be positive. Now it's only ever going to be either between the two numbers or outside of the two numbers. It's never going to be anything else. You're never going to get a random mix. So either your values are going to be between 4 and 7, or they're going to be less than 4 and greater than 7. So if I'm here and I go, that's positive. Whereas if I go in between and I read off a value, it's negative. So I want where it's positive, which in this case is when x is less than 4 and x is greater than 7. Okay, right. The other way to do this, or it shouldn't really be and, but we don't even need that actually. Let's take that and out and not confuse you. So, because you wouldn't have two answers at the same time. So technically, me sticking an and there wouldn't be correct, although you would get all the marks. So you'd have, let's have a look, and you'd make sure you put them both in your answer. Right, like that. The other way is we've got this 4 and 7. We know it's got to be between them or it's going to be outside. So I pick a number. 0 is usually the best number if 0 is not one of your answers. So I could have 0 minus 0 would just leave me with plus 28. And you'd say, is 28 bigger than 0? Yes, it is. Which means 0 has to be part of my solution. 0 is less than 4. So it's the outside bit. So x is less than 4 and x is bigger than 7. So I think a graph sometimes is easiest to see. It's that region there, but you can do it any way that makes sense for you. Okay, let's have a look at the next question. Okay, now comes the bit that's new for you, and that's having simultaneous equations with 3 bits in them. Okay, so let's have a look and let's think about how we're going to do these. So what we want to do is essentially we want to end up with exactly the same as what we do with normal equations, which is having essentially 2 simultaneous equations to calculate it from. So let's have a look. Right, there's a few ways you can substitute. You can look at what's the same and eliminate something and end up just with A's and B's. It honestly doesn't matter. I think sometimes the easiest way is to look for things that look obviously will be able to take away from each other. So I'm going to label them 1, 2, and 3. I can see if I do 1 plus 3, because can you see the C's are the same there, so they're going to cancel out. So if I do 1 plus 3, what am I going to get? I'm going to get 2a plus 6a, so I'm going to get 8a. b plus 3b, so 4b, equals 8 plus 0, which is just 8. And so I've got one equation. And then the next one, I want to get rid of the c from here. So I could do equation 2. I could take equation, let's do this actually. Let's take equation 3. I just think adding is easier than taking away, then you're not thinking about the minus and the minus. And I'm going to multiply that by 2. So that gives me 12a plus 6b plus 2c equals 0. And if I rewrite equation 2 underneath, 3b minus 2c equals minus 9. What I can now do is add those two equations, and I end up with 16a plus 3b equals minus 9. So now I have two equations here. I've got two equations here with a and b as my unknowns. Right. So I could double this top equation. So let's call that 4 and 5. You don't need to number them. I think it just makes it easier for you to follow. So 4 times 2 is going to give me 16a plus 8b equals 16. And now I can take them away from each other. Right, so I can do 3 minus 8, which is going to give me minus 5b. And I've got minus 9 minus 16, which gives me minus 25. So I can see that b equals 5. Right, now I can find a. So I'm going to sub that into any of them. Let's sub that into number 4. So I'm going to get 8a plus 4 times 5 to give me 20 equals 8. So 8a equals 8 minus 20. Oops. So 8 minus 20 to give us minus 12. So a is going to be minus 1.5, so 3 over 2. Okay, so I've got both of them. I could plug them into any of the equations to find c. So let's say sub into 1. So I'm going to have 2 lots of a. I'm going to write it down here. 2 lots of minus 3 over 2 plus b, which was, what do we say? b was 5. Minus c equals 8. So we get minus 3 plus 5 minus c equals 8. And that's going to give you 5 minus 3, which gives you 2. So 2 minus c equals 8. So c must be minus 6. So your answers are minus 3 over 2, 5, and minus 6. There are loads of ways to do this. But essentially you want to eliminate something to end up with a simultaneous equation that you recognize. So you eliminate the same thing, but you have to use all 3 equations at some point. So one equate will use 2, and then the second batch uses the other 2. Find 2 of them, substitute it in to find the third. Okay, I think that's right. Okay, proof. Everybody doesn't like this, but it's a really nice topic. You just need to know a few rules. So first of all, you need to know what an integer is. An integer is a whole number. So you may have to deal with integers. You may have to deal with natural numbers, which are counting numbers. And at that point, you can think about odd and even numbers. So if we think about it, what is an even number? An even number can always be written as 2n or 2x or 2 something. Now an odd number is always 1 more than an even number. So an odd number is going to be 2n plus 1. Okay, and if something is divisible by something, it means you can take that number outside of the bracket. So if I have a 5 outside of a bracket, it means the whole bracket is divisible by 5. So we've got now, show that all of this is divisible by 9, which means hopefully when we open out the brackets, we can take a 9 outside of it. Okay, how do we open out 2n plus 3 cubed? Now you could use your Pascal's triangle. Alternatively, you could do 2n plus 3 squared and multiply it by 2n plus 3. So we'll get 4n squared, 6 double 12n plus 9, multiplied by 2n plus 3. I'm doing this quite quickly. Obviously, take your time and write it all out. And then you're going to have 4 times 2. So 2n squared. Yeah. So we're going 4 times 2 here. So we're going to get 8n cubed plus 36n squared plus 54n plus 27. Okay, then to that we're adding n cubed. So then we've got 2n plus 3 cubed plus n cubed. So you're going to get 9n cubed, 36n squared plus 54n plus 27. And then you can take 9 outside the bracket. 4n squared plus 6n plus 3. And you could write a concluding statement, or this would show it anyway. Therefore, that's what those 3 dots mean, divisible by 9. Right, next one. Prove that something is always bigger than 0. So let's just start off by opening it all out, because as it stands, it's not going to be something we can, again, I'm going to open it out quite quickly, pause this, try opening it out yourself and double check you get the same thing. So we're going to get 9x squared, and the way I do it quickly, just so you know, is take the first value, square it, 9x squared, times the 2 together, 3x times 5 gives me 15x, and double it. I get 30x plus 25 minus these 2 multiplied, 5x squared minus 50x. Okay, and when I simplify that, I'm going to get 4x squared, 30x minus 50x, so minus 20x plus 25. Now, if it is always bigger than or equal to 0, I'll be able to write it as an exact square term. So I'll be able to do something, all squared. Okay, so let's think about it. Take the first one, that's going to give you 2x. If you take the square root, that's going to give you 5. You want minus 20, so you can put a minus there. And you could prove it to yourself by opening it out. And you can see that this is always bigger than or equal to 0 as square number. So whenever you want to prove something is bigger than 0, you've got to show it's a square number. The other method you could use is using the discriminant. Now the discriminant, if you remember, is b squared minus 4ac. In this question, a is 4, b is minus 20, and c is 25. So we get minus 20 squared minus 4 times 25. Okay? And you could calculate that. And if your answer would be, so let's work it out, we'll get 25 times 4 times 4, which is 400. 20 squared is 400, which is 0. And because there's only one root, which means it's bigger than 0. Because 20 squared is 400, so there's one root. So we know if we were to do the equation, it would be like this, and it would always be positive. Okay. Sequences. Nth term and limiting value. Right, so this topic looks a little bit scary. You only really need to know the mechanics of it. You don't really need to, I'm just gonna double check, I didn't miss a question, no. You don't really need to know exactly how it works, but it's good to know, right? So generally, if I take any value, what can I never, ever divide by? So I can never divide by 0. So I can never have 1 over 0. It's illegal. It doesn't work. Okay? So if I've got something with a 0 on the bottom, I know it's just gonna, because you can't do 1 divided by 0, right? It's gonna tend, what we say is it tends towards infinity. because it's infinite. It goes up and up and up and up. Okay. And also, what else? So sequences, we talk about things tending towards things. A nice way to think about it is think about your 1 over x graph. If x gets bigger and bigger and bigger, so x is getting bigger, so it's going towards infinity, so it's getting bigger and bigger and bigger, y tends towards 0, because it tends towards our asymptote, but never ever ever reaches it. Okay, so let's think about a strategy of how we're going to approach this. Right, in terms, there's no limiting value in the first bit anyway, so it's saying the kth term, so instead of n, we're putting k of sequence A, so k 14k plus 30 is equal to putting k into sequence B. Okay, what are we going to do now? We're going to cross multiply. So that gets multiplied by that. So you get k squared equals 2 14k plus 30. Open it all out. We get k squared equals 28k plus 60. Move everything onto one side. And we have a quadratic. Now, if it's a calculator paper, use your calculator to help you factorize it. Although if we think about factors of 60, we could have, with a difference of 28, hopefully you're going to think, oh, it's not going to be a huge number. So it's not going to be like a long way down. So 60 and 1, we go, okay, we've got 60 and 1, that's not going to give me a difference of 28. 30 and 2, perfect. 32 minus plus. So then we end up with k equals minus 2 or k equals 30. Which one of those doesn't make sense? Can we have a minus term of a sequence? We can't we? So we've got the first term, then the second term, and the third term. We can never ever have a minus term. So we're going to cross that out, and we've got k equals 30. Okay, now we're going to look at the limiting value. So we're doing as n goes towards infinity. Right. One way to do this, remember if we have 1 over n, we can say it goes towards 0. So this is more so you understand it. You may have learned just to sort of cross out the n's. But what we're going to do is we're going to divide every single thing by n. So the top one's going to be 3n divided by n, 1 over n, because as long as we do something to everything, it makes sense. Now as n gets bigger and bigger and bigger, 1 over n goes towards 0. So then my whole thing must go towards minus 3 over 2 because the n's go towards 0. Right, work out the position of the term that has a value 0. Now remember, we can't divide by 0, but 0 can be divided by anything. So the top would have to equal 0 for that to happen. So 5n would be 1420. Okay, so n equals 1420 over 5. We could double both of them and then divide by 10. So you could see it's actually double that. So 284. And now we've got to think about the limiting sequence. And now let's do it in that same way. So we're going to make sure we end up with divide everything by n. So we get 1420 over n minus 5 over 1420 over n plus 5. So as n goes to infinity, 1420 over n goes to 0, which leaves you with minus 5 over 5, which is minus 1. So your answer is minus 1. Things first, we're going to look at equation of a line. So we know that an equation of the line is in the form y equals mx plus c. M is your gradient. So this tells you about your slope. So it's going to be positive or negative depending on whether you're sloping up or down. The higher the number, the steeper the slope. Plus c is your y-intercept. Now your y-intercept is when x is 0, what is y? So it's where you cross that vertical axis. There's a few equations that we need to know. Our gradient is our y2 minus y1 over x2 minus x1. You might have done it as rise over run, change in y over change in x. That's all this is, but in equation form. And an equation of a line, we learn a new way to write it. You can always substitute your gradient and your points in and find your plus c. But this just makes it easier. So in further maths, we find this easy way to find an equation of a line. Right, let's look at some questions. So we're given a straight line passes through some points. We want to work out the equation. Step 1, I'm going to find the gradient. So I'm going to say my m is, let's label these, x2, y2. So y2 minus y1 over x2 minus x1. So we get minus minus, so that's going to become a plus. So we've got minus 9 over 3, so we've got minus 3. Now I'm going to use that equation. Y minus y1, and I can use either of the points. Just going to use the first one. No reason why. Actually, it might have been easier to use the second one. So then my mx minus x1. You open that out, we get y minus 11 equals, now this is going to make a plus, minus 3x minus 3 times 2, so minus 6. So y equals minus 3x minus 6 plus 11, so we end up with plus 5. So y equals minus 3x plus 5. Okay, next one. We've got points with a gradient again. We're looking at gradients. So x1, y1, x2, y2. We're going to get our gradient, which is going to be y2 minus y1 equals x2, which is a, minus x1, which in this case is minus 3. And we know that equals 12. So we get b plus 10 over a plus 3 equals 12. Okay, let's multiply this bit underneath up here. So we're going to get 12 times a to give us 12a, 12 times 3 to give us 36. And what we want to do is, I think it's quite easy to find an expression for b here. So we'll get 12a plus 26, and then we can just substitute values in. It says integer values, so we want whole numbers. So pick a number. I'm going to say if a is 1, it's probably the easiest one. B is going to be 12 times 1, 12 plus 26, which is 38. So here's an example. You could have chosen 0 and you'd have got 0 and 26, or anything like that. It's only 2 marks, even if they've left us a lot of space, but that's all we need to do there. Okay, so now we're going to look at a midpoint of a line, or somewhere along the line, not necessarily the midpoint. If it was exactly the middle, if we have 2 coordinates, to find a point exactly in the middle of those, you add up the x's, you divide it by 2. You add up the y's, and you divide it by 2. And that would give you a coordinate of exactly halfway. Or you could say, how much have I moved up and down, and split that. And that's what we're going to be doing here. So we know that this is split in the ratio 5 to 2. Right, what we're going to do first is find our differences. So how do we go from 5, how do we go from 3 to 5? We're going across 2. And then if we want to go from 7 to 5.5, we're going down 1.5. So we're just looking at how much each bit of the space is. Now, this 2, if you like, is worth 5 bits, and we want to work out how much 2 bits are. So we're going to take that 2, divide by 5, and then times by 2, which will give us 4 over 5, which is 0.8. So now I know that across here, I've got 0.8. Now, for the 1.5, we're going to do exactly the same. Now, because I'm going to assume it's if it was in a non-calculator, dealing with fractions is a bit easier. So I want to divide by 5, and I want to times by 2. So that's going to give me 3 over 2 times by 1 over 5 times 2. And when I do that, I end up with, well, that cancels, and I end up with 3/5, so 0.6. So I know this bit is going to be changed by 0.6. So now I'm saying my 5, I'm going along an additional 0.8. So 5 plus 0.8 is going to give me 5.8. And 5.5, I'm going down by 0.6. So 5.5 minus 0.5 will take me to 5, minus that extra 0.1 is going to take me to 4.9. And that's me splitting that line up, just thinking about the ratios. Okay. Now we get to use our midpoint. So we get told M is actually the midpoint of the line AB. So we know this is our x1, y1, x2, y2. So I know if I add up minus 2 plus 7 and divide it by 2, I'm going to get P. And 3 plus R divided by 2 is going to give us minus 1. Okay, so from the first equation, we can see that minus 2 plus 7 is going to give us 2p. So 5 equals 2p, so p must be 5 over 2, or 2.5, depending on whether you like to write them as decimals. And then r is going to be 3 plus r equals minus 2. So then we're just going to say, well, r must therefore be minus 2, minus 3, so we get minus 5. Okay. The next topic is looking at the intercept of a line. So that's where something crosses an axis. So actually, let's have a look. There's lots of different types of intercepts. So if we take an equation, let me take a purple line here, and let's draw a blue line like that. Okay, so let's look at some coordinates. This here is where the purple line intercepts the y-axis. It's my y-intercept. So this would be 0, and it would be some y-coordinate. Sub-0, y1, let's say. And this as well would be a y-intercept. Here is where the blue line, so I know the purple line even, crosses the x-axis. And at that point there, that's an x-coordinate, and the y is 0. And where two lines meet, that's also called an intersection. So you've got to really think, like if they say, what is the intersect of the x? People normally immediately put x is 0. That's wrong. It's y is 0. So when you intercept the y-axis, x equals 0. And when you intercept the x-axis is when y equals 0. Okay, let's have a look at some questions. So we've got L is a straight line. At which point does it intersect the x-axis? So intersecting the x-axis means y equals 0. So when all of these y equals 0, but I'm going to make y equal to 0. So ax, b times 0 is just 0. So ax equals c. So therefore x must be c divided by a. So my answer would be here. Right. What is the gradient of a line parallel? Okay, when two things are parallel, their gradient is exactly the same. So if we have this, I can't see what the gradient is yet because I need it to be y equals mx plus c. So to find the gradient, I'm going to rearrange it to make y the subject of the formula. So I'm bringing the ax to the other side, becomes minus ax plus c. And now I have to divide by b. So putting everything over b, I can put each bit individually over b. And now hopefully you can see that this bit here is your gradient. If I compare it to the options, it's going to be that one there. Okay, now they've got to work out the point of intersection of the lines. Okay, so we've got simultaneous equations again, just in context. It's what we use them for. So we've got 2x plus 3y equals 11. I'm going to bring that 3x over and we get 3x plus 2y equals 13. We want either the x's or the y's to be the same. So I'm going to make the x's the same. I'm going to times this one by 3 and this one by 2. So I'm going to get 6x plus 9y equals 33 and 6x plus 4y equals 26. So that's my 1 and my 2. That's my new 1, my new 2. I can take them away from each other. 9 minus 4 gives me 5y. That gives me 5y equals 7. So y is 7 over 5. I substitute it back in. So I might want to write that as 1.4. And I substitute it back in and get 3.4. If you want to go through this slowly, we've done it in the algebra section. There was the exact same intersection question when we were talking about simultaneous equations. Okay, now we've got equations of 3 lines. The lines intersect at the points O, A, and B, as shown in the sketch. Show that the length of OB, so let's find the length OB. So let's take OB, which is here, is equal to the length AB. So we're saying this yellow line is equal to that. Right, how are we going to go about doing that? We've been given the equations. We first need to identify, well, no, they've told us which one is which. Okay, so we need to identify some coordinates. If I want to find out the distance, the first thing I'm going to have to do is I'm going to have to work out the coordinate here and the coordinate here. Okay, so the coordinate of B is when 2x meets this graph here. So we've got 2y equals 11x minus 7 and y equals 2x. So this is easy because you've already got y equals something. You can just substitute the 2x. So the whole of the 2x can go into the y. So we get 2 lots of 2x equals 11x minus 7. 4x equals 11x minus 7. So we end up with 7x, 11 equals 7. So x is 1. Now if x is 1, y must be 2. So we know this coordinate here is 1. So 2 times 1 is 2. 1, 2. Okay, which makes sense. It's in the positive axes, so we're all good here. Right, now let's find A. A is when this line here, which is this, meets this line here, which is this. So let's solve those two simultaneously. So we're going to have 2y equals 11x minus 7 and x plus 3y equals 0. Okay, so again, a substitution might be easier because we can take this and just move that 3y. So x equals minus 3y. So we get 2y equals 11 lots of minus 3y minus 7. So 2y equals minus 33y minus 7. Add that onto that side. So we get 35y equals minus 7. So y equals minus 7 divided by 35, which is going to give you minus a fifth, which is minus 0.2. Then we can sub it back into here. Minus and minus make a plus, so plus 0.6. So this is going to become plus 0.6 minus 0.2. Right, so now we've got our points. We want to find the distance of OB. Left space there. So the distance of O to B, and we're going to find the distance of A to B. Okay, O to B, let's think about this. That's our coordinate, is 1, 2. So all we're doing is the change in y, is drawing a triangle, because you're looking at how much different it is. So from 2 to 0 is 2 and 1. So O to B is going to be Pythagoras of 2 squared plus 1 squared. So I'm just going to leave it as square root 5. A to B is going to be your change in the x's squared minus the change in y. So let's think about a generalized difference between 2 points. It's always going to be x2 minus x1 squared, y2 minus y1 squared, and the whole thing square rooted. So in this case, we're going from a to b. So we've got 1 minus 0.6 squared plus 2 minus 0.2 squared. And then when we stick that into our calculator, this is calculator paper, we get root 5. And then we'll just say OB equals AB. So that shows how you find the length or the distance between 2 points. But it's mainly surrounding the intersection of them as well. Okay, parallel lines. We talked about this briefly when we came up with the question, but parallel lines are lines with the same gradient. So it's when the m are exactly the same. So y equals 7x plus 4 is parallel to 7x minus 3004. Doesn't matter what the plus c is. The bit we're concerned with is the gradient, which is the bit in front of the x. Okay, here we go, saying write an equation that is parallel to this. We've got a problem, we don't know what the m is because we need y equals. So we're going to divide both sides by 2. So we get y equals a half x, so we know the gradient will be a half. So we've got y equals a half x plus some c. We know when x is 4, y is 0. Don't be tempted to sub in c is 4 because it's the other way around. So let's substitute it in. So when x is 4, y is 0. A half times 4. So 4 divided by 2 is 2. So c must be minus 2. So my equation is y equals a half x minus 2. Actually, let's write that a bit neater. So we've got y equals a half x minus 2. Okay, so I hope that makes some sense. Right, now we've got a quadrilateral. What does that mean? So all a quadrilateral is essentially a four-sided shape. We're told that M is the midpoint of PS. Okay, well, we can find M. We know how to do that, don't we? We add the x coordinates, so 6 and 4, and we divide by 2. And we add the y coordinates, and we divide by 2. So when we do that, we get a P and S, yeah. So when we add the x coordinates, we've got 6 plus 4, which gives us 10 divided by 2 is 5. So that must be 5. 11 plus 1, which is 12, divided by 2, which is 6. So we've got 5, 6 as our midpoints. We want to use the gradients to show that MR is parallel to PQ. Okay, so we're going to find the gradient for each bit. Right, so let's do PQ first. So PQ. So for PQ, if I do x1, y1, x2, y2, and I'm going to take away. So we're going to do minus 3 minus 1 over 10 minus 4. Now, if you look at the slope, you're expecting a negative slope. I've got minus 4 over 6, which is minus 2 over 3. Okay, so that's the gradient of PQ. If I want, I could put an M here or even write gradient. And now I want a gradient of MR. So for M to R. So I'm looking for this one here. Okay. And I'm going to do exactly the same thing, right? And I'm trying to show that they're parallel. So I want to show my change in y over my change in x is exactly the same. So if I do 0 minus 6 over 14 minus 5, I've got minus 6, and then 14 take away 5 is 9. That also cancels down to minus 2 over 3. And so you're going to say MPQ equals MMR, therefore parallel. And you've shown your work and got your marks. And I think this question in total was, it's just 3 marks. Well, still, it was still 3 marks. Okay, next question. We've got a point on a circle and the equation of a circle. Okay, so what is the general equation for a circle? So your general equation for a circle is x squared plus y squared equals r squared. And that tells you that the center is 0, 0, and the radius is r. However, that center could shift. If it shifts, instead of x, it's x plus, remember x's do the wrong thing, so x plus 1 if it shifted to the left on the x coordinate, or if it shifted to the right. Okay. And every single point around the whole curve will satisfy that equation. Okay, let's show you what that means. So we've got an equation here. We've got x squared plus y squared equals 29. So that's saying the center is 0, 0, and the radius will be root 29. Okay, so that's what my equation is saying. And I want to show that P is on the circle. So I have my circle, I have my center, and I know this coordinate here is somewhere on the circle, which means it satisfies this equation. This is the x, this is the y. So I've got minus 5 squared plus 2 squared gives me 25 plus 4, which equals 29. So therefore I have shown that it satisfies that equation. It really is that straightforward. Okay, now what did we say? Sometimes the center shifts. And when it does, we have x minus a squared, y minus b squared equals r squared. And that's when the center isn't quite 0, 0. Right, so we've got a circle center C, and it touches the y-axis at the point 0, 2. And the line y equals k intersects the circle at 1k and 5k. And we've got to work out an equation of the line. So we need to work out how far in and out the line is. So what the center is and what the radius is. Okay, so if we're going to go from the center to the edge, we've got this line here, we can see that we're going from, this is 0 to some point here. How am I going to find that point? So if I have a look, I've got these 2 bits that cut it across. That's called cutting a chord. So if I draw a line up here, this gives me a radius as well. So does this. But if I go halfway, I'm going to cut this exactly in half. Okay. Right. Now remember, the general equation is going to be x minus a squared plus y minus b squared equals r squared. So all I know at the moment is that my center is in line with y equals 2, so I know the y coordinate of my center is 2. Okay, so that I can see really clearly. Right, I also can see my x coordinate, because if x is 1 here and x is 5 here, and this cuts it right in the middle, my x coordinate must be the middle of 1 and 5. So 1 plus 5 is 6, divided by 2 is 3. So I get x minus 3 squared equals r squared. And remember, every point along the circle satisfies that equation. So I'm going to substitute this point in. So I'm going to get 0 minus 3 squared plus 2 minus 2 squared equals r squared. So you're going to get r squared equals 9. And so my final equation is going to be x minus 3 squared plus y minus 2 squared equals 9, which I could have seen because I know that the x goes all the way out. Right, let's have a look at the next equation. So we have two circles, each with a center 0 as shown. Okay. Work out the perimeter of the shaded section ABCD. Okay, so we've got a quarter of a circle that's been shaded. So let's have a look at what we're going to do with this. So first of all, we can use these equations to tell us the radius. So the radius of one of them is going to be the square root, because remember we've got x squared plus y squared equals r squared. So the square root of 289. So here the radius is 17, and here the radius, you hopefully recognize, is 11. So we know this space is 11, okay, and we know all of this is 17. Now the bit that's shaded is the big circle minus the small circle, okay? But in terms of perimeter, we're not looking for the area, we're looking for the perimeter. So we're looking for this bit, and then these two bits. So the easy bits are the two bits that we can find. So this is 6, and this is 6. This bit here is part of the circumference. So if you remember, the formula for circumference is 2 pi r. So if I say small circle is going to be 2 times pi times 11, but I've only got a quarter of it. So I'm going to divide that by 4. Okay? Right, and the large circle is going to be 2 times pi times 17 divided by 4. So when I add those up, work them out, so I get 2 times, it's a calculator, divided by 4 gives me, it doesn't say how many decimal places. Okay, so we can leave it as 5.5 pi, and 2 times pi times 17. So 17 times 2 divided by 4 gives us 8.5 pi. So we're going to get 8.5 plus 5.5, so 14 pi plus 12. Now, if it was a calculator paper and they may have asked for it in terms of decimal places. If this was the case, then you would just substitute in 3 significant figures. Here, because it's not clear, you could do any one that you liked. Okay. All right, so now we've got an equation of a circle, and this one's a little bit trickier. So if you have a look, you've got x's and y's, and they've all shifted. So it's not quite x squared plus y squared. What you're going to do is you're going to take your x squared section and you're going to complete the square. And you're going to take your y squared minus 6y and complete the square for y. So half what's in front of the y, square it and take it away. Now we're going to put it all together. Equals 0. We can move the numbers onto the opposite side. And remember, x minus a squared plus y minus b squared equals r squared. AB is your center and r is your radius. So here we can see straight away that our center is 1, 3 and our radius is root 10. Okay. So now we're almost there. We're looking at the equation of a tangent to a circle. So those of you doing Edexcel GCSE, they've also on the advanced information explicitly said this is actually going to be in the GCSE specification as well. That should really be a straight line. I don't think I've drawn it very straight. Let's try again. So, okay, let's draw that as a tangent. So that's just meeting at one point. Okay, so from the center to a tangent, we know we get a right angle. So if this is my AB, and if we call, actually let's call this XY, the gradient from AB to your x1, y1 is going to be perpendicular to the gradient of the tangent. Okay, let's work through an example and that's going to make more sense. So we've got a circle. So we're given a circle here and we're given a point. So let's draw the tangent here as well because I know I'm going to need it. Okay, so we've got a circle, center 0, 0, because it's just x squared plus y squared. And there's a point here which is -5, 2. We want to find the equation of the tangent to be able to find where it meets the axes. Okay, so step 1, we're going to find a gradient. So we're going to find the gradient of this line here to start with. So we've got our change in y over our change in x. So if we have a look here, we can say so it depends, like I said, we can use y1 and y2. We can do our rise over run. It doesn't really matter. So we've got our m, which will be -5 minus 0 over 2 minus 0, so -5 over 2. Okay. And we sense check, is it negative? Yes, we've done that right. Now the tangent is the inverse reciprocal, which means you flip it and you change the sign. So if that's the m of the radius to the point, then m of the tangent is 2/5. Now we know P is on that line. So we can use y minus y1 equals m x minus -5. Right, so we've got y minus 2, and this is where this equation comes useful. We don't need to rearrange it. We just want to find out where it intersects the x-axis. So it intersects the x-axis when y equals 0. So when y is 0, we get 0 minus 2 equals 2/5 x plus 5. So x plus 5 equals -2 times 5 divided by 2. So -5. -5. So x equals -10. So your x coordinate will be -10. Okay, let's have a look at the next one. So we've got another one. We've got a circle C as an equation, and P and Q are points on the circle. The tangent at Q is parallel to the x-axis. The tangent of P and Q are set. Okay, write down the coordinates of C. Okay, so that one's easy. So remember our equation, x minus a squared plus y minus b squared equals r squared. So if that's 1, our x coordinate is 1. This is plus 3, so our y coordinate is -3. Okay. Show that the equation of the tangent is y equals 2. Right, so we want to know from here to here, if the radius, so r squared, so if we know r squared equals 25, r must be 5. So if this is 1 minus 3, and this is 5, -3 plus 5 equals 2, therefore y equals 2. So we're going straight up by 2. Okay, nice. Work out the x coordinate of r. Okay, so we want to work out this coordinate here, which means we need to work out the equation of this line. To do that, we first need to know the equation of, or the gradient of this line. So we want to know the gradient of the line from C to P. Okay, how are we going to do that? We do our y1 minus y2 minus y1 over x2 minus x1. So we want this equation here. So if we have a look from -3, so from -3 to -7, so if you think about that, that space is 4, and from 1 to 4 it's 3. So, and it's a negative line. So we've got minus 4/3. And we've got the 4 minus 7. Okay, so we've got 4 minus 7 as our thing. And our m of c to p is minus 4/3. So therefore, the gradient of the tangent is the inverse reciprocal. Remember, flip and change the sign. So 3/4. So we do y minus y1 equals m x minus x1. And we're trying to find out where that meets this line here, which we know is the line of y equals 2. So we substitute in y is 2. So we get 2 plus 7 equals 3/4 x minus 3. So 2 plus 7 plus 3 gives us 12 equals 3/4 x. So x is going to be 16. The x coordinate is 16. The first bit of this topic is about rate of change. Now, essentially, it's a fancy way of talking about the gradient. So dy dx, which we know as the gradient function. But essentially, it's your change in y over your change in x, which is, when you have a straight line, for example, how you work out the gradient. So it's how something changes with respect to something else. So we've got a grid, we've got to sketch a graph. A rate of change of y with respect to x is always 0. So essentially, when is a gradient 0? Now that's going to happen when you just get a horizontal straight line. So as you change the x coordinate, the y coordinate doesn't change. So we end up with a horizontal straight line. It says on the graph, the rate of change is always positive. So here, what we need is a straight line just with a gradient of 0. And it doesn't matter, it doesn't need to go through 0, 0. We're not talking about directly proportional. It just needs to be a positive straight line. Might as well do it through 0, 0, but there's no reason to. Okay, now we've got 5 graphs. And the question asks us different things about it. So the first bit is the rate of change is always negative. So that means it's always negative, so it's always going to be sloping downwards no matter which point we look at. So if we have a look, that's going to be graph C. So graph C, we know, is always negative. Okay, the next bit says, is always 0. So exactly like we just drew the other one, we're essentially looking for a horizontal straight line. So we've got this one here. So this is always 0. And the last bit says, as x increases, the rate of y with respect to x decreases. So we're saying as x goes up, right, the rate of y decreases, so the gradient decreases. Now when we've got a curve and we want to think about the gradient, we're just going to think about the tangent at lots of different points. Now if we have a look, we start off with a steep line over here and it's less steep and less steep. So the answer here would be A. Right, next bit is differentiation. And this is quite a nice topic because all you do is when you have something to differentiate, so you'll have y equals x to the power, let's put a number in front, so k x to the n. dy dx, all you do is you bring that number down and you multiply by that power. And then you take 1 away from the power. So you multiply by the power and you reduce the power by power and you reduce the power by 1. So with this question here, we've got 2x to the 10 minus 3 over x squared. So before we can start to do this, our first step is going to be to rewrite this indice in a way that's easy for us to differentiate. So we've got 2x to the 10. Now because it's on the denominator, we're going to bring it up. And when we do so, that 2 becomes a minus 2. So now when we do dy dx, we multiply by the power 2 times 10 to give us 20x to the 9. And then we bring down this one. So minus 3 times minus 2, which is plus 6x, minus 2 minus 1 gives us minus 3. So be super careful with negative numbers. We've got some more here. Now when we've got something with something on the denominator, we want to be able to split it out. So we split the numerator. So this is the same as saying 2x to the 7 over 3x plus 15x squared over 3x. So if we take the first bit, we'll get 2 over 3. And we can cancel down. So we've got x to the 7 divided by x. Now remember, when we divide indices, we're taking away. So we get x to the 6. 15 divided by 3 gives us 5. And then x squared divided by x, 2 take away 1 is x. Now we're going to differentiate it. So remember, we multiply by the power, 6 times 2, giving us 12. Divide by 3 is going to give you 4. So we're going to end up with 4x to the 5 plus 5. Because remember, 5x, the gradient of y equals 5x, is just 5. So we want to know what that equals, what x equals when all of it equals 133. So I can take away 5 from both sides. 133 take away 5 is going to give me 128. If I then divide by 4, 12 divided by 4 gives me 3, 8 divided by 4 gives me 2. And you should know that the fifth root of 32 is 2. So your answer is 2. Next bit says, work out the rate of change of y with respect to x at a certain point. Now remember, rate of change, just a fancy way to say differentiate. So step 1, we're going to open out those brackets. X squared times x squared is going to give us x to the power of 4 minus 9x squared. And now we're going to differentiate it because they've asked us for the rate of change, which essentially means that they want you to differentiate it. So when we differentiate that, we multiply by the power, so bring that in front, reduce the power by 1, 4 take away 1 is 3. Same here, minus 18x. And now we're saying when x equals minus 2, what does dy dx equal? So we're going to get 4 times by minus 2 cubed minus 18 times minus 2. So 2 cubed is 8. So we've got minus 8 times 4 to give me minus 32. 18 times minus 2 is minus 36. Minus and a minus make a plus. 36 minus 32 to give me 4. Okay, the next bit, we're looking at the gradient of a curve. Now, exactly the same. Rate of change, gradient, all of these things are different ways when we talk about dy dx. So when we think about a curve, so any curve at all, if I take a random curve, if I wanted to know what the gradient was there, I would have, in GCSE, you draw a tangent, you'd find change in y over change in x. That's all dy dx is telling you. It's giving you, if you substitute the x in, what the gradient will be at each of those different places. Okay, so let's take this first one. We've got work out the gradient when x is minus 1. It's given us dy dx. So essentially, all we're going to do is substitute in some values. So when we substitute our values in, we've got 9 minus -1 cubed. Now, even though you might be able to do that really quickly in your head, just write it out. You know, 9 minus 9 plus 1, so the answer is 10, just to avoid making any silly mistakes. Right, work out the value where the rate of change of y with respect to x is 1. Again, rate of change, same as dy dx. So we've got 9 minus x cubed equals 1. X cubed is going to equal 8. So x must be 2. Because the cube root of 8 is 2. Right, slightly longer question here. We've got a curve has an equation. The gradient, we see gradient, my brain's going to go dy dx. So first let's just work out dy dx. Bring the number down, the power down, and take 1 away. So we get 3x squared plus 2ax. Now we're saying when x equals 4, what is dy dx? So when x equals 4, dy dx is going to be 3 times 4 squared plus 2 times a times 4. So that's going to give us 4 squared, 16, times 3, so 48. 2 times 4 is 8, so 48 plus 8a. Okay. And when x equals -1, dy dx is going to be 3 minus 1 squared plus 2 times a times -1. So we're left with -1 squared, which is just 1, times 3, plus, well, it's going to actually give me a minus 2a. And now what does the question say? The one when x equals 4 is twice x equals 1. So that tells us 48 plus 8a is twice, so 2 lots of 3 minus 2a. So when we open out those brackets, we've got 6 minus 4a. Put all the a's on one side. So you're going to get 8 plus 4, so 12a. And then you're going to have 6 minus 48. So you get minus 42. Divide them and you've got minus 3.5. So your answer would be minus 3.5. And that's 5 marks. It's quite a lot of marks. And you just follow that process. Okay, so we've got a curve, y equals fx. dy dx has given us what dy dx is. When x equals -2, the gradient is 12. Okay, so we're going to substitute in x is -2. So when x is -2, dy dx is going to be 3 over 2 times by -2 minus k times -2 to the power of 4 plus k. And we know all of that equals 12. So now if we sort that out, we've got -2 is going to cancel there. We're going to get -3. -2 to the power of 4, giving us 16. So we've got -16k plus k equals 12. Move the k's onto one side. We're going to get 15k equals, so if we move the k's onto there, we've got -3 minus 12. So we've got -15. So k must equal -1. And you may have rearranged that differently, but you should get the same answer. Okay, next bit. Matrix multiplications. I know I'm talking fast, but please, make sure you pause this video, go back over it. It's just so if there's only certain questions you got wrong, you can sort of zoom through them. When we multiply matrices, you do each row of the first matrix multiplied by each column. So your fingers kind of do that. So you go along and down. Okay, So if I was to take, so everything is pairwise. Now, when we multiply a matrix, it goes on the front. So if you do A multiplied by B, it's BA, not AB. So each row is multiplied by each column. Now this will make more sense when we have a look at a question. But also remember that your calculator, if it's in the calculator paper, I know that's after half term and it's still a little bit a while away, like well after half term. So if it's in the calculator, you can use your calculator to multiply them, but they'll be worth a lot less marks. Okay, so we've got AB equals C, right? So A, now A is a 2 by 2, because you've got 2 rows and 2 columns. B is a 2 by 1. Rows go first and then columns. So you've got 2 rows and 1 column. Now you can only multiply things if these 2 middle bits are the same. And you will get these 2 outside bits. So we've got 4 minus 1 minus 7, 2, multiplied by S minus 5 to give us minus 1t. So you're multiplying each row by each column. So essentially you've got 4 times 5 plus minus 1 times minus 5. Sorry, not 4, it's not 5, that's an S, apologies. Let's write that more clearly, S. So you've got 4S minus 1 times minus 5, making plus 5 equals minus 1. Okay, so we can solve that quickly. Bring the 5 onto the other side. So we get minus 6. So S is minus 6 over 4 minus 3 over 2. You might have written it as 1.5. Next one, we've got minus 7 times by the S, 2 times minus 5, and that equals t. So we end up with minus 7s minus 10 equals t. But we know s is minus 1.5. So we're going to do minus 7 times by minus 1.5. So you're going to end up with 10.5 minus 10, which must be 0.5. So s is minus 1.5 and t is minus 0.5. Excuse my voice. And then we've got AD equals I. Now what does that I mean? So that's your identity matrix. So I equals 1, 0, 0, 1. Essentially it's like timesing by 1 for matrices. When you multiply by I, you just end up with the same thing. So if I have A multiplied by I, I'm going to end up with I multiplied by A, which is just A. Okay, so A, it tells us, is 4 minus 1 minus 7, 2. So 4 minus 1 minus 7, 2. D is 2, 1, 7, U. And we're saying this equals 1, 0, 0, 1. So we know when we do this row, because this is the second row, by the first column, I get 1. So minus 7 times 1 plus 2u equals 1. So we get minus 8 plus 2u equals 1. And work out the value of u. So we've got A multiplied by D multiplied by D minus 7 plus 2u equals 1. Oh, I've made that 8 somehow. I wondered what I'd done wrong. I wish I could say it's to see if you're awake, but here we go. So minus 7 plus 2u equals 1. So 2u equals 8. So u equals 4. There you go. I knew it had to work out nicely. Also, in an exam, that's quite a good sense check. If you're getting a number that looks a bit strange, you might have done something wrong. So have a double check and go look back. Okay, Next question, work out the values of A and B. If we've got a number outside, it means everything is multiplied by that. So here, this means 3A and 5A. And on this side, we've got 4 times 2, so 8A plus 12. So it's like having a number outside of a bracket. So now I've got 3A equals 8A plus 12. So if I put all the A's on one side, 8 minus 3 is going to give us 5A equals 12. So A is, so if we do 8 and then we move minus 12, doesn't matter which way you do it. Whether you put the 12 on that or the one or the other side, just make sure you get the minus in. So A is minus 12 over 5. And then we've got 5A equals 4B, but we know that A is minus 12 over 5. So we get 5 times minus 12 over 5 equals 4B. So we've got minus 12 equals 4B, so B must be minus 3. So minus 12 over 5 and minus 3. The next one, we've got an identity matrix again. So we're going to be multiplying this out. So remember, we've got the first row times by the first column. So you're going to get 2 times m to give you 2m, minus 1 times minus 2 to give you plus 2. And remember, the identity is 1, 0, 0, 1. So that equals 1. Then here you've got so then you can choose another equation. So let's do the one with 0. So we've got our first row, this time multiplied by our second column. M times 2, 2m. Minus 1 times minus 1 is going to give us plus 1, and that equals 0. And so we've got 2 equations. We could use either of them to work out m. I would use the first one. So we get 1 minus 2, so minus 1, m equals minus a half. And I would check it with the second one. So 2m equals minus 1, m equals minus a half. Because remember, you're in the exam, you want to try bring in checks wherever you can, just in case. Okay. We all know Pythagoras. A squared plus b squared equals c squared. And we do that using A only if we have a right angle triangle. But when we're squaring something, particularly if we have x's or various numbers, we've got to make sure we square everything. So get used to writing the whole of whatever your A is inside a bracket. Okay, so here we want to find A to C. So we've got a right angle triangle. We're going to do A squared plus b squared equals what we're trying to find squared. So we've got AC squared is 3x, this is what I mean by brackets, all squared plus 4x all squared, which gives us 9x squared plus 16x squared, which gives us 25x squared. And then we're going to take the square root. Square root of 25 is 5, and we get AC equals 5x as we needed to. So that's what we wanted to get, and we've got that now. Okay. Part B, we want to find the area of the quadrilateral. Okay, let's have a look at the quadrilateral. So we now know this is 5x, and they want the area of this entire shape. So 1, 2, 3, 4, which is why it's called a quadrilateral. And so we could say, okay, let's find the area of the other triangle, well, both triangles. We could start with the area of this triangle at the bottom, because it's a right angle, so it's easier. So we've got half the base times the height. So we're going to get 4 times 3, which is 12, divided by 2, which is 6. So the smaller triangle at the bottom is going to be 6x squared. And then we've got this other triangle at the top. Now, in order to find out or do anything with this triangle, we're going to need to find out an angle somewhere. Yeah. So what do we know? We're told that ACD, we're told this is isosceles. So we know that the base angles here are going to be the same. So the first step we're going to have to do is going to be to find that angles. But because it's an isosceles, what we can also do is split this in half. So we don't need to worry about any rules. And when we split it in half with a beautiful perpendicular line, which mine wasn't, you're going to get a right angle here. And this will be half and this will be half. So as I have to redraw that triangle, just half of the triangle, I'm going to have my right angle. That's my right angle. Actually, let's draw it the other way so it's facing the same way so you can see what I'm doing. So we're drawing here, here, here. We've got a right angle here. So the angle that I'm drawing is going to be, the triangle, sorry, that I'm drawing is this triangle here, which is going from D, if I call this just sort of midpoint, and C. We know that bit across is 5x, so this must be 2.5x. We don't know the height dm, but we know D to C is 6.5x. Now, in order to find out the area of the triangle, we want to find out this angle here. So we can find out this angle here. We've got the adjacent and we've got the hypotenuse. So using SOHCAHTOA, we're going to use cos. So we can see that cos x equals 2. So cos x equals 2.5x over 6.5x. These cancel. So I'm just calling this angle x. I know it's confusing. We should have probably called it x. Inverse cos of that, it gives me an answer of 67.4. So now I have an angle. I can use that same triangle formula, half base, or half A, B, sine, and then sine C. Right, we're going to stick that all into our calculator. So we're going to, without the x obviously, so 0.5 times 5 times 6.5 times sine of 67.4, which gives me 15.000. And then we've got x, which is x squared. So I'm going to say that's 15x squared. We had this 6x squared from the smaller triangle. So we add them up and we get 21x squared. Okay, the diagram shows a rectangle this time. So we've got a rectangle, we've got some measurements, and we want an expression. So don't freak out if you get asked for an expression for the area. All you're doing is finding something in terms of x and y. Okay. And here we want, in its simplest forms, in terms of only y. Okay. So the first thing we're going to do is we're going to say the area of a rectangle is base times height. So we'll get x times 2x, which is 2x squared. It's the area. But we've got no y's there, and they want it in terms of y's. So we've got to say, what's the connection between the three lines that we've got there? The connection between those lines is Pythagoras. So we've got x squared plus 2x all squared equals 4y squared. So we'll get x squared plus 4x squared equals 16y squared. Now we want to find out what 2x squared is in terms of y. So we've got 5x squared is 16y squared. X squared is 16 over 5 y squared. Therefore 2x squared is 32 over 5 y squared. And that would be our answer. Okay, next question. We've got a cone with a vertex and a center. The slant height is 20. The angle between VA and VC is 38 degrees. So let's think about what that means. So VA and VC, where do those two lines meet? At V. So this is the angle that's 38. And we want to work out the radius of the base. Okay, so that's quite nice. We've got SOHCAHTOA, right angle triangle. And so what do we have? We want to find the opposite, and we have the hypotenuse. So we know that sine 38 is r over 20. So r must be 20 sine 38. When we stick that into my calculator, I'm going to get, 20 times sine 38. I'm going to get 12.3. And that's going to be the radius of that base. Okay. The next topic is 3D trig. So we often need to find, when we've got 3D trig, what we're looking for a lot of the time is like a triangle floating in 3D. Okay, I'm incredibly bad at drawing this, so let's see if we can draw something, otherwise I'm going to have to show you with an example probably. So if I have a 3D sort of cube, and what I would be looking for, so maybe I need, you'd have, say for example, a floating kind of triangle over here, inside this cube, right? What you have to think of is that everything is right angles. And sometimes they don't give you the side lengths, but they tell you it's a cube. So if they do that, make sure you choose the length to be either 1 or 2. So when you half it, if it's midpoints anywhere, you get to use it like that. So 3D trig is just about creating lots and lots and lots of triangles and remembering there's like right angles everywhere in a cube. Okay, or in a 3D shape. If it's something like this, which is a cuboid. So it's telling you that they want you to work out the length of AB. So let's see what we know. We know that HB is 34. We know that HD is 16. AD is 18. So we've got a few things there, and we want to find out A to B. Now what we can find easily, based on the information we have, is D to B, because we've got a triangle here. Remember, everything is right angles when we've got cuboids, and so we can use Pythagoras to find DB to start with. So D to B is going to be DB squared plus 16 squared is going to equal 34 squared. So DB squared is 34 squared minus 16 squared, which comes out to be 900. So DB must be 30. So now we've got 30, and then we've got another right angle triangle. So if we want to find out AB squared plus 18, AB is my hypotenuse. So we're going to have, this again, 18 squared plus 30 squared equals DB squared, right? No, ignore me entirely. DB squared is my hypotenuse. Okay, let's try to do this properly. Apologies for that. Right, where is my right angle in this triangle that I have? I'm going to have DB squared minus 18 squared. So DB is my right angle, because my right angle is here, on the bottom here. See, you can see that AB is going to be your so DB is going to be your, oh my God, I can't get my words out today. So DB is going to be your hypotenuse, so which we know is 30, right? So let's rewrite this. Let's go again. Oh, we're going to end up with 18 squared plus AB squared equals 30 squared. So therefore AB squared equals 30 squared minus 18 squared. So AB equals the square root of that. So 30 squared minus 18 squared, which gives us square root the answer, which gives you 24, which makes more sense. There you go. All right, so let me go through that again and hopefully haven't confused you too much. This one at the bottom is your right angle. You're going to have right angles on the sides here and along the bottoms here. Okay? Right, so you'll have to excuse whatever confusion I caused. Right, next one. We're going to work out the angle between HB, which is drawn there, and ABCD. Now, the nice thing is they've drawn you the triangle, essentially. So the angle that you're looking for is essentially this angle over here. So if I was to take this triangle, I know the opposite and I know the hypotenuse. So I'm going to use so sine. So I'm going to have sine x is opposite over hypotenuse. So sine to the -1 is going to give you 21.8 degrees. And that, hopefully, I know I've spoken for so long, so please, do what you need to there. Use as much or as little as you need. So that is everything we have for geometry. I'm going to upload this just as a screen record at the moment, and we will prettify it and put it up properly for you. But just so at least you've got you've got it there. We'll try get that up for you tonight. Okay, I hope that's useful. Sign up for the course next week if you need it. We'll be going through some more papers and just lots and lots of questions. And what I'm going to try do as well is give you a summary of everything. So just like a really quick summary of some notes, and if you like, almost like a cheat sheet for your further maths. Right, hope that's useful. And any questions, ask away.